Let's do another working together problem. Again, we're going to get an equation that's a quadratic, so we'll have two solutions, and we have to decide then whether we keep both of them or only one is viable. First, a quick reminder that if you can complete a job in 4 hours and you're working at a steady rate, how much of that job do you get done in 1 hour? And I hope you're thinking 1/4. And if you recall, when we're giving a rate in relationship to someone else, then we may more likely than not, have a variable in the denominator. Here's our problem. I'd like you to pause the video, write it in your notes, hit play when you're done. So we're trying to determine how fast Peyton can clean the house. Please enter this chart in your notes as well. See if you can fill it in. Once you're done, hit play. Oh, let's fill in the chart. We know that Eli is a rate we do not know, but we know that Peyton can do it 3 hours faster. So faster means in less time. We write each of their part of the job done in an hour as a fraction, as we've done before. And we are told that together they can get the job done in 2 hours, which means every hour they're getting 1/2 of the job done. So the equation that we're going to use is here, adding this together to get then this 1/2. So we get 1/t minus 3 plus 1/t, and that's equal to 1/2. We do need to look at the LCD. We're going to clear those fractions, so we're going to multiply by 2, a t, and a t minus 3. And the reason why we multiply by all three of these is because they're relatively prime and we can't pull any common factors out. So if you would please multiply this equation by that LCD when you're ready. So pause the video. When you've done that, hit play and let's take a look. So we have this equation. We are able, for the first term, to divide out that t minus 3 to get 1 times 2t all over 1, because when these divide out, you get a 1. For the next term, the t divides out, and so in the denominator, again, we get a 1, and so we just get the numerator, and that is 2 times t minus 3. On the right-hand side, the 2 divides out, giving us a 1 in the denominator, and t times t minus 3. Let's go ahead and distribute across all of those. Remember, distributing means multiplying in here. So when you do that, you get 2t plus 2t minus 6 equals, so that is, 6, won't erase it. Got it. So you get 2t minus 6 and equal to t squared minus 3t. And let's collect like terms. On the left-hand side, you get 4t minus 6. On the right, t squared minus 3t. And let's take all of the terms to the right-hand side. So we're going to subtract 4t and 6 from both sides, so that we get 0 equals t squared. Minus 3t minus 4t is minus 7t. And then plus that 6. That is a quadratic. We're able to factor it. Please pause the video, factor it, use the 0 property, and then come back and check your work. Factoring, the middle term is negative, This final term is positive, which means the two factors have to have the same sign. This tells you those factors are negative. We have to add to 7. We do have factors of 6 that are 1 and 6 and 2 and 3. We need the 1 and 6 because they add to 7. And then set each of those factors equal to 0. That's a 0 property. Add 6 to both sides, add 1 to both sides. And now we have to decide whether we get to keep both of these or only one of them. If you remember, Peyton can do the job in 3 hours less than Eli. If t is how long it takes Eli to do, we can't have 1 minus 3 is negative 2. Peyton can't do the job in a minus 2, or it's done like 2 hours ago. So this one has to get thrown out, and instead we just keep t equals 6. And remember, Peyton can do it in t minus 3, 6 minus 3, which is 3 hours. So Peyton can do the job, which is cleaning the house, in 3 hours. Now please remember, this one was a little different because our answer wasn't 6, so it wasn't that Peyton can do it in 6 hours. It was t minus 3, so always remember to go back and look at the original problem. If you would like some extra practice from your textbook, go to page 142 and question number 33. Hope you're having a great day.